integration of x tan square x dx. Now the ideal situation is we need something that we can use fundamental rule of calculus. We cannot use tan square as the fundamental rule of calculus because we cannot integrate this. So but we can integrate sec square because according to the fundamental rule of calculus that can be done. So that means when we have d by dx of tan x, we get sec square x. So when we integrate sec squared x by the fundamental rule of calculus, we can write tan x. But when we differentiate something, we never get tan square x. So this is basically, we cannot use by parts, because if we consider this to be dv by dx, we cannot integrate this and find v. So we have to do some adjustment to this particular sum. So the adjustment that needs to be done over here is we can use the identity that tan squared theta plus 1 is identical to sec squared theta. That means we can write tan squared theta as sec squared theta minus 1. That is the adjustment that we can make. So by making that adjustment, we can write x sec square x minus 1 dx. So we can write x sec square x minus x dx. So we can write integration of x sec square x dx. I'm separating the two integrations because they're added up, meaning using this minus sign is known as addition rule. So whenever you see the addition rule, you can write if it is integration of u plus or minus v, you can write it as integration of u plus or minus integration of v. So that's what I did. I just separated these two, and that is going to be integration of x dx. So we know integration of x sec square x dx minus integration of x is going to be x squared by 2. Since there is still a little bit of integration left, not little bit, major part of integration is left, so I'm not going to write plus c over here because plus c is written after the end of indefinite integral. So we need this part. So whenever you have a situation like this, you can separate this math. I'm going to write this as I for integral. So I is basically integration of x sec squared x, that is going to be I. So uv, so x is u, so v, now by the fundamental rule of calculus, we can say sec squared integration is tan x, so this is going to be tan x, minus integration of v, again it is going to be tan x, into d by dx of x is 1 dx. So we have x tan x minus integration of tan x dx. Now we already know that there is a special rule for integration of tan x, and that special rule is integration of tan x dx is ln of sec x. So using that special rule, we can write x tan x minus ln of sec x. I'm not writing plus c here because the math is still not done. There is another, the main part is over here. So now we can get back to this and write down the answer. So integration of x sec square x is x tan x minus ln of absolute value of sec x, because logarithm cannot be negative, minus x squared by 2. Now we can write plus c, and this is the math using identity and finally integration by parts.